over 1, so on and so forth. Okay, we draw a line through that. Okay, and it's pretty good. All right, second equation. Okay, y equals x minus 3. Our y-intercept is -3. Okay, and we go up 1 over 1, up 1 over 1. Okay, and continue that idea. Good Lord, that's awful. And then we can go from here, we can go down 1, back 1, down 1, back 1. Okay, draw a line through that. Okay, and we look at our point of intersection, which is, okay, right about here. Okay, which is our solution. Okay, and that's the point 1, -2. Okay, if you plug 1, -2 back in, okay, if x is 1, 3 times 1 is 3, 3 minus 5 is -2, so y is -2. If x is 1, 1 minus 3 is -2, okay, which is what y is supposed to be here. Okay, the second one here for substitution, okay, we want to take one of these equations and make them either x equals or y equals. The easy one to do that for would be the bottom one, okay, make that y equals, subtract 2x. So we have y equals -2x plus 14. Okay, and then we're going to take the -2x plus 14 and we substitute that right in there for y. So what we wind up having, okay, after we substitute that in for y, is 3x plus 4 times -2x plus 14, all right, is equal to 31. We distribute, so we get 3x, 4 times -2x is -8x, 4 times 14 is 56, okay, equals 31. Combine like terms, -5x plus 56 is equal to 31, subtract 56, -5x is equal to -25, divide by -5, and we get x being +5. So that's our first value. Now we have x's and y's in here. So let's take that, let's plug it right in for x in that equation. So we have y equals -2 times 5 plus 14. So y is equal to -10 plus 14. So y is equal to 4. So our final solution, which we always will write as an ordered pair, is going to be the point 5, 4. Okay, now we talked about when graphing isn't the best method. Okay, that's if you happen to wind up with fractions. Very tough to graph fractions, and if you get solutions that are fractions, you can't tell when they intersect if it's a half or a third or a quarter or whatever it is. Now we're going to get when substitution isn't the best method. Okay, now here when we solved for y, it was very easy. We got y equals -2x plus 14. But what if we wound up solving for y and we got a couple nasty fractions in here, which we then had to plug in, multiply by something, still winding up with nasty fractions, okay? There's a third method that we could use, okay, that's going to help us out. Now, what we talked about here, remember we talked about graphing not being affected if we do not get integer solutions, that I just mentioned. Using substitution can be difficult if it isn't easy to solve one of the equations for a variable because you wind up with fractions, okay? For example, look here, okay? It's not easy to solve for either x or y in any of these equations, okay, because you wind up getting fractions, okay? Even if you look at the bottom one, okay? For example, if you have the bottom equation for x, you have to subtract 8y and you divide by 3, okay? You wind up with x equals -8 over 3y plus 53 over 3. Then you got to take this, plug it in there, multiply times 5. Nothing cancels for us. So elimination isn't the substitution. Isn't the best method here. We want to look at something that's called elimination. Okay, in elimination is basically it's a 5-step process. The first step is to make sure both equations are in standard form. Okay, if you remember standard form, that's x and y are on the same side. The constants over here. Okay, now true standard form is when the x term has to be positive. Here we're not that concerned about it. We just want to make sure that x is over x, y is over y, the equal sign is over the equal sign, and the constant terms are by themselves. Okay. Now, here's the important step here. We want to multiply the equation so the coefficients of one of the variables are opposites. All right, now what does that mean? It doesn't matter which variable you cancel. You have the option to cancel either one, okay? If I want to cancel the x's, okay, I have a 5x and a 3x. I want to try and multiply the top equation and the bottom equation by numbers that will give me opposite numbers, okay, opposite coefficients for the x's. Now the easy one thing to do is multiply the top by the bottom by the top, and you got to play around with your negative signs. So if I multiply the top by 3, which is the coefficient of the x here, 3 times 5x is 15x, 3 times negative 3y is negative 9y, and 3 times 23 is 69. Now I have a 15x in the top equation. I'm going to have to multiply the bottom by a negative 5. Now up here it says positive 5, but if I multiply by negative 5, that'll give me a negative 15x, which will cause the x terms to cancel or be eliminated. Okay, minus 40y equals negative 5 times 53 is negative 265. Okay, now third step is to combine the two equations. Here are my two equations. Okay, if I combine them, I have 15x and negative 15x, which just cancels for me. Negative 9y and negative 40y gives me a negative 49y. Okay, and 69 and negative 265 gives me negative 196. Okay, here's my new equation. Very simple to solve this. Okay, step 4 says to solve it. All right, I want to divide both sides by negative 49. Okay, and that's going to give me y equaling 4. Now, if you remember back in the other problems, we had to always figure out what both x and y were. So I need to take the y being 4, okay, and plug it into one of these original equations. It doesn't matter which one. Okay, I'll take y being 4, plug it into the bottom one. So I wind up with 3x plus 8 times 4 equals 53. Okay, 8 times 4 is 32, so I have 3x plus 32 equals 53. Subtract 32 from both sides. Oops, that should be a plus here. So 3x equals 21. Divide both sides by 3. I get x equaling 7. Again, we want to write our solution as an ordered pair. So our final solution is going to be x being 7 and y being 4. Okay? Now, if you were to go and do this by substitution and take this expression here, plug it in for x, you would still wind up with the same answer of 7, 4, but it would be a little bit more obnoxious to do it because of the ugly fractions. Now also in this problem, I chose to cancel the x's. If I had chose to cancel the y's, I have a negative 3y and an 8y. I would have probably chosen to multiply the top equation by 8, which would have given me a negative 24y over here. Multiply the bottom equation by 3, which would give me a positive 24y, and cancel it. If I had done it that way, I still would wind up with the same answer. Okay, now let's flip to the back. Let's look at a couple of these. Okay, solve each of the following using elimination. So now, the first step is to make sure they're lined up correctly, which they are. Okay, in this case, the easy variable to cancel out again would be the x. Okay, reason is, I already have a positive 4x. I could take the bottom and multiply it by negative 4, and that'll give me a negative 4x. Okay, essentially I'm multiplying the top equation by 1, but I don't have to worry about writing that out. Okay, 1 is the coefficient here of this x in the bottom equation. So we have 4x minus 3y equals negative 12, and when I multiply the bottom by negative 4, I get a negative 4x minus 16y equals negative 64. Okay, now, just like in the problem before, which it should always do for us if we do this right, 4x and negative 4x cancel. Negative 3y and negative 16y give me a negative 19y. Negative 12 and negative 64 give me a negative 76. Divide both sides by negative 19. And coincidentally, I get y equaling 4 again. Okay, I'm not done because I've got to figure out what x is. So I'm going to take this y being 4. I'm going to plug it into the bottom equation here. And I'm going to get x plus 4 times 4 equals 16. So x plus 16 equals 16. Subtract 16 from both sides. X equals 0. So my final solution is 0, 4. Okay, if I had chosen to cancel the y's, which would be a little bit more difficult, you got to multiply top and bottom by equations by number, I'd still get the same thing of 0, 4. Okay, now look at this second problem here. I changed one thing. I don't remember what I changed exactly, but make sure that on your worksheet that this looks exactly the same as that. I think I threw a negative here on the negative 3x. Okay. But look at this problem. Unlike this, the first two where it was easier to cancel the x's, it's actually easier in this problem to cancel the y's. Okay. Reason is I can just multiply the top equation by a positive 4 to give me a 4y, and the bottom equation would already be a negative 4y, so that the y's would cancel. If I wanted to cancel the x's, I'd probably multiply the top by 3 to give me 6x, the bottom by 2 to give me negative 6x, and those would cancel that way. Either way, I wind up getting 8x plus 4y equals 60. Okay, the bottom equation isn't going to change, so I have negative 3x minus 4y equals 10. Okay, our 4y is going to cancel for me again. All right, 8x minus 3x gives me a 5x. 60 and 10 is 70. Divide both sides by 5, and I wind up with x equaling 14. Now again, I'm not done. Okay, I'm going to take this 14, plug it into the top equation. Doesn't matter which equation you plug it into, but I'm going to plug it into the top because we just have a 1y here we're solving for, which will make it easier. Okay, so we have 2 times 14 plus y equals 15. 2 times 14 is 28. So 28 plus y equals 15. Subtract 28, we get y being negative 13. So my final solution, when I write it as an ordered pair, is x being 14 and y being negative 13. Okay. Now, what I want you to do is I want you to pause this and go and figure out, try and solve the next two on your own, and then come back and check what the answers are after you do that. Okay, hopefully you've gone and solved it. Okay, solved the next two. Okay, if I go through for number 3, in this case, unlike numbers 1 and 2, it's not easier if I solve for, if I can't solve either x or y. It doesn't really matter. All right, I'm going to cancel out the y's. Okay, because I hate the Yankees, and Yankees start with y, so I want to get rid of them. All right, so the best thing to do would be to multiply the top by 7. Okay, so 7 times 10x is going to give me 70x. 7 times 3y is 21y, and 7 times 5 is 35. Again, notice at the beginning of the problem, it was already set up in standard form for me. Now, if I multiply the top by 7 to cancel the y's, and I get a 21y, I'm going to want to multiply the bottom one by negative 3 to give me a negative 21y. So this gives me minus 9x minus 21y equals negative 96. Okay. Now, when I combine my two equations, okay, again, the positive 21y and negative 21y cancel. 70x minus 9x gives me a 61x equals 35, and negative 96 gives me a negative 61. So x is equal to negative 1. Take this, plug it into one of these equations. Doesn't matter which one. I'll plug it into the bottom one. So I have 3 times negative 1 plus 7y equals 32. Okay, 3 times negative 1 is negative 3 plus 7y equals 32. Add 3 to both sides. 7y equals 35. Divide by 7. I get y being 5. So my final solution is going to wind up being negative 1, comma 5. All right. And the last equation, this is the first one that we came across that was set up that was not in standard form for us. Okay, it's not lined up. We have x on this side by itself and y in the constant term over here. We have y on this side and x in the constant term over here. So what we want to do is move the y in the top equation to the other side. So we get negative 3x minus 4y equals negative 3. And in the bottom equation, we want to move the negative 3x over. So we get a positive 3x plus 2y equals negative 3. Now, it just so happens that with the x's, you have a negative 3x and a positive 3x. So the way it's set up, they're already going to cancel for us. If it wasn't, okay, if it was basically more set up along the lines of this, where we had coefficients that weren't opposites already, we'd have to then go and do step 2, which we did here. We multiplied by 7 and negative 3 to cancel the y's. Okay, we'd have to multiply both equations by something to get the coefficients to be opposites. However, the way it's set up for us, it's nice. So we can just go and eliminate right away. The x terms cancel. Negative 4y and 2y gives us negative 2y. Oop, that should be a negative 3 here, not a negative 6. I'm sorry about that. Oops. It happens. Okay, so then negative 3 and we combine them, we get negative 6. Okay, but divide both sides by negative 2, and we get y being positive 3. Okay, now I'm going to take the y being 3. I can plug it either into these equations or the originals. Okay, I'll plug it into the top equation of the originals. All right, so I plug 3 right in here, so we get negative 3x equals 4 times 3 minus 3. Okay, so then we get negative 3x equals 12 minus 3. Okay, 12 minus 3 is 9, so negative 3x equals 9. Divide both sides by negative 3, and we get x being negative 3. So our final solution is x being negative 3 and y being positive 3. Okay. Now again, you can always go and check to make sure your answers are right by taking your final solution and plugging it into the equations that we used originally to make sure that it checks out for you.